Good morning, dear students. Let's start with a new unit, Surface Chemistry. Surface chemistry deals with the phenomena that occurs on the surfaces or interfaces. What is an interface? Interface is a line of demarcation between two bulk phases. Say we have two bulk phases, one liquid phase and one gas phase. The line that separates the two phases is known as a interface. Then this interface is generally a few molecules thick, but the area depends on the size of the particles which are present in the bulk phase. Now gases do not have any interface, that is, there is no line of demarcation between the gases because they are completely miscible with each other. Many important reactions like corrosion, electrode reactions, heterogeneous catalysis, dissolution, crystallization, they all occur at the surface or interface. So, surface chemistry has many applications in industry, analytical work and in daily life situations. In order to attain a very clean surface for surface studies, we have to subject it under high vacuum. Then only such ultra clean surfaces can be provided to us. And after attaining such ultra clean surfaces, we again need to store them in vacuum. Otherwise, they are going to be covered by molecules such as oxygen, nitrogen. In this unit, we will be studying about adsorption, catalysis, colloids, which include emulsions and gels. Let's first study about adsorption. Now, what is an adsorption? See, for example, let me give you an example that you are sitting on your study table and there is a lot of dust. The dust is present only at the surface. So, we will call the dust particle as adsorbates and the table as adsorbent and the phenomena as adsorption. Let me give you the definition of adsorption. It is the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. The molecular species or substance which concentrate at the surface is termed adsorbate. Like I gave you the example, dust particle is the adsorbate and the material or the surface on which adsorption take place is called adsorbent. The table is the adsorbent. Now adsorption is a surface phenomena only. We talk about only the surfaces and not the bulk. The materials which are good absorbents are the ones which are in finely divided state, or when the materials are in finely divided state, they have large surface area. Thus, charcoal, silica gel, alumina gel, they act as very good adsorbents. Let us see adsorption in action. For example, you have a closed vessel and that closed vessel has number of gases like oxygen, hydrogen, chlorine, ammonia. Definitely when these gases are enclosed in a vessel, the vessel is going to have certain pressure. But when you put powdered charcoal, the pressure of the gas in the enclosed vessel decreases. Why? The reason is that the powdered charcoal absorbs all the gases and thus the pressure of the gas in the enclosed vessel decreases. Let us see one more example. For example, we are having a solution in which a dye is present. Say methylene blue is a dye. You have worked with this dye while you had stained the cheek cells in your junior classes. So what we do, in this solution having methylene blue, we put animal charcoal. What happens? The animal charcoal absorbs the dye and we get a colorless solution, or we can say the filtrate is colorless. So the animal charcoal had absorbed the dye, which is the colored part, and the filtrate becomes colorless. Let's see one more example. The raw sugar is generally having certain straw colored. It is a straw colored liquid. And then what is done, in order to make it clear, we pass it over the beds of animal charcoal and then it becomes colorless. The coloring substance gets absorbed by the charcoal. Now, you know that when you buy shoes or sometimes some packets come at home, they are having small sachet of silica gel. It is written over there. The purpose of this is that silica gel absorbs the moisture. So that is the air becomes dry as it absorbs the moisture. So this again is an example of adsorption, that this air becomes dry in the presence of silica gel because the water molecules get adsorbed on the surface of the gel. Now let's see what we mean by desorption. Whatever has been adsorbed on a surface, if you remove that, then that phenomena is known as desorption. Thus, the process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. I hope you are now familiar with the term adsorption, adsorbate, adsorbent, and desorption. Let's discuss about the difference between adsorption and absorption. In adsorption, the substance is present only at the surface, but in absorption, the substance is distributed uniformly throughout the bulk of the solid. Let's see here, in adsorption, the particles are concentrated only at the surface, but in absorption, the particles are present distributed uniformly in the bulk. Let's take an example of the chalk stick which is dipped in ink. Now you know that ink is generally blue in color. So what happens? We find the outer surface of the chalk is colored, right? But if we break the chalk, we find that there is no color inside. It is only white in color. This means that the ink contains certain dyes and solvent. The dyes get adsorbed on the outer surface of the chalk, and the solvent that goes deeper into the chalk stick, and so the inside of the chalk stick is white in color. So the color outside, blue color, is an example of adsorption, and the inside of the chalk is colorless. This is an example of absorption. Let's take one more example. Let's see the difference between absorption and adsorption by taking the example of water vapor. Now we have, say, anhydrous calcium chloride and silica gel. This anhydrous calcium chloride will absorb the water vapor, but silica gel will adsorb the water vapors. Right? Now, if both adsorption and absorption take place simultaneously, then we use the term sorption. Now let's see the mechanism of adsorption. The adsorption occurs because the particles which are present on the surface of the adsorbent are not in the same environment as the particles which are present in the bulk. Let's see here. For example, this is a particle which is present in the bulk. Now this particle is experiencing equal and opposite forces, and thus we say it is experiencing balanced forces. But we see the particle on the surface. The particle on the surface do not have atoms or molecules of its kind on all sides. So it experiences the unbalanced attractive forces. These forces are responsible for attracting the adsorbate particles on its surface. So that means the forces which are present, such unbalanced forces of the adsorbent are responsible for attracting their adsorbate particles on the surface. Now as the surface area increases, the extent of adsorption also increases. So we can say here that adsorption occurs because of unbalanced forces. That is, the forces of the adsorbent are responsible for attracting the adsorbate particles on the surface. And greater is the surface area, greater is the extent of adsorption. We can also say that let's study one more factor regarding adsorption, that is the heat of adsorption. You know, when there is adsorption, there is always a decrease in the residual forces of the surface. See, every surface has a demand. When particles start coming on the surface of the adsorbent, then what happens? Its demand to accept more adsorbate particles decreases. That means we can say that the residual forces decreases. Now whenever there is a decrease in the force, there is going to be a decrease in the energy, and whenever there is a decrease in the surface energy, then that decrease appears in the form of heat. So we say that adsorption is an exothermic process. We always say that for adsorption, delta H of adsorption is always negative. I hope this is clear. Now when the molecules, they are adsorbed, then what happens? Their freedom of movement also becomes restricted. When this results in decrease in the entropy of the gas. So we can also say that delta S is negative for adsorption. Now you know that Gibbs-Helmholtz equation, which is delta G is equal to delta H minus T delta S. We have studied that delta H of adsorption is negative. Now you know why it is negative. Again, let me explain. Delta H is negative because when the surface start attracting the particle, after some point of time, the attractive forces decreases, and when there is a decrease of attractive forces, then the surface energy decreases, and that energy appears in the form of heat. And you know, when the heat comes out of the system, then delta H is negative. Also, when particles, they are moving here and there, when they settle on the surface, their disorder, their randomness decreases, and whenever there is a decrease in randomness, the delta S becomes negative. Now you can say here that this is for delta H and this T delta S is positive. Now for process to be spontaneous, delta G should be negative. Now delta G should be negative only, delta G can be negative only when delta H is greater than T delta S, because then only delta G can be negative and the process can be spontaneous. Now then we can also say that as adsorption proceeds, a time comes when delta H becomes less and less negative, and ultimately it becomes equal to T delta S, and at this point delta G becomes 0 and we say that equilibrium has been attained.